on just a couple of the printers. There may not be any time at the end for questions, but don't worry, I'll be contacting each of you to ensure that if you have any questions that they all get answered. First of all, I'm Paul Sesto. I'm Javelin's 3D printing education specialist. I've got both a science and engineering background along with industry experience with 3D CAD and 3D printers. And I'm speaking on a daily basis with Canadian teachers, educators, professors, and technical staff from elementary and high schools and colleges and universities and research centers. And I'm also lately talking with people at public libraries because it seems to be a hotbed for 3D printing too. Javelin sells and supports the Stratasys line of 3D printers, the world's leader in 3D printers. And so with me today is Jesse Rottenberg, Stratasys North American Education Manager. And Jesse literally has the pulse of what's happening in all levels of education for 3D printing, both in North America and from his Stratasys colleagues around the world. Many of you may know something of Javelin, but we keep growing and expanding our 3D technology offerings to both our industry and education clients. I'm out of the Oakville office, but I have the support and resources to help all of our Canadian education clients from my colleagues, as we have offices in Halifax, Winnipeg, Calgary, Edmonton, and Surrey. Javelin's been around for 17 years, and most people know us as the #1 SolidWorks reseller and support company for both industry and education. And having Stratasys and SolidWorks together, it's one of the things that help differentiate us from others, because we can put together both the 3D content from the CAD side with SolidWorks and the 3D printing with our Stratasys printers. Javelin's been in the education market in the 3D sector, and we have over 130 Canadian schools as our clients. And we also have, on the industry side, about 4,000 clients across Canada for all of our technologies. Jesse, are you there? Hello, Jesse. Okay, I don't know if I've connected up with Jesse, so I'm just going to continue on here, and if I hear him click in, then I'll turn the mic over to him. With Stratasys, sorry, Jesse?
Oh, I am here.
Oh, okay, Jesse.
Yeah, I'm here. I'm sorry.
Okay, we've got up, I think you see your Stratasys screen there. If you can give us a few words on some background on Stratasys.
Absolutely. Thank you for sharing the time, and thanks to those that are on the line. Stratasys, we've been around for a long time. A lot of people have just heard of 3D printing in the past, 3 to 5 years, but our company's been around for 26 plus years. The technology is, at least within us, has been really honed. What you see today is the buzz of 3D printing came about when it became more affordable in office, in classroom, and now we're seeing lots of educational aspects of it. Students are getting excited about engineering. They get to apply what they learned due to the fact that they now have the ability to manufacture in the classroom and then test things that they've done. It's truly exciting, and it's a huge boost to those engineering, those STEM areas, because you get that hands-on, that real-world experience. The students love it because they actually get to create something. They get to go run home to mom and dad and say, "Look what I made," rather than a "What'd you do in class today?" Nothing. And then on top of it, industry loves it because these students are graduating from college and university, even high school. They're going to these companies and they're changing the way these companies work due to the fact that they know the ins and outs of the tools necessary, the CAD, and then the fact that additive manufacturing is a huge piece of it. And so you've got this great relationship of education wanting it, needing it, 3D printing, industry, it changing the way they do business, saving time, money, and allowing them to be more of risk takers. And it created this perfect storm of the avenue we need to go down. Next slide, please.
Yep. So with these two leading technologies, we've got on the FDM side, we've got functional, strong parts with the PolyJet, on the PolyJet side, we've got realistic parts with possibility of digital materials and a whole variety of materials to produce parts that feel and look like what is going to be produced in the in production. With Stratasys, they've divided their printers into sort of 3 areas that I'll just get into briefly. Their Idea Series, Design Series, and Production Series. And it's the Idea Series, the printers are the Mojo and the Uprint that we really look at as being used in schools for the elementary and high schools. They're safe, reliable, robust machines. It's plug and play. They can print what others can't. And in choosing a printer, you really want to be looking at what is it you want to do? What are your goals in 3D printing? Is it functionality? Is it precision? Also, what are the size of parts that you want to build? Of course, budget is important. You also want to look at where you want to go in the future with 3D printing, so you're really buying for the future. Another very important aspect when we're talking to people is with technical support. Remember, and I want to just point out with Stratasys, all of our printers are commercial grade printers, and because of that, they know how important technical support is for both industry and education clients. And if your budget is limited, perhaps to what we call the consumer hobby level, one piece of advice that we want to give to people is just make sure that you know beforehand what support that printer is going to be given by either the producer of that machine. With our printers, as I said, they're commercial grade printers. The whole idea is that you don't want to have disappointments with a printer not working. You want to keep learning on track. It's built, the Mojo and the Uprint, they're built to be working for every student, every school, and basically every day. Our design series of printers, this is usually an ideal fit for colleges and universities. We have a level of printer both with FDM and with the ObJet printer. In some schools, and we even see that they are getting one of each machine, so that they have machines that will do both types of printing. With the production series of machines, these are our high level, our largest machines from Stratasys. We're really looking at the top end or sort of enterprise printers. This would be the example of servicing perhaps the entire college or university campus. This is actually what's being starting to known as 3D printing super labs, where departments and faculties are actually pooling their resources financially and staff so they can get the top end of 3D printing that, as I said, would service the entire the campus. At the for education, in industry, it's really all about getting to be first to market, getting your products out there. In education, it's really about, when we talk to people, it's really about the journey. The 3D part is the destination, but what are the students learning to get there? So it's really that journey, and then that's part of what we talk about with the curriculum too. 3D it's sparking imagination, it's getting students at all ages interested in science and technology, and also when we talk about STEM programs, we also talk about STEM programs too, and that's the sort of STEM, I'm getting these mixed up, STEM with the creativity of the arts added in there. The other thing too, I won't read through this slide, but the other thing too that the 3D printing is doing, it's also getting girls interested in design and engineering. So they're right in there with the guys doing robotics, doing the 3D printing, and the design. And that's actually helping to promote more girls and women to go into technical programs, go into mechanical engineering, and so forth. Just going to turn this back over to Jesse.
Thanks, Paul. One of the areas that we see, people ask us, how young are people using 3D printing? we've got some organizations, the Starbase organizations that are a group in the United States that they're teaching at the Department of Defense bases. And at these bases, they're teaching students at the 4th through 6th grade level. Everybody asks, well, how, you know, fourth graders can't learn how to use CAD. These kids are doing it. I actually had one of these students teach me how to use CAD. I'm not a CAD expert, and I was at an event with the Starbase group, and this young 12-year-old taught me how to extrude, taught me how to lift, taught me how to remove sections to put a hole in. And so very exciting. A truly authentic engineering experience. These kids are not only learning classroom learning, so learning the key attributes, but then actually putting these attributes to the test. They have a summer program where these kids actually get to build the nose cones and the fins for their rocket. Simple little pieces. They're not, you know, it's not too in depth on how to design it, but it's a physical piece that they create. It's theirs. Then they get to launch these rockets and see how they test versus their friends. These guys get to make engineering decisions. Another cool thing at these Starbases is it's the instructors that are going above and beyond, and they're creating teaching tools. This printer isn't just used to print objects for the students, but it's also to create lesson tools where they can show how drag works, or they're showing how they're creating custom jigs to help with an internal air launching piece. They're printing pieces to use in their wind tunnels. So it's truly a cross the program piece of equipment that makes the student experience and the instructor experience really go the entire way, which is launching even better learning. What we're also seeing is they take a survey at the beginning of all these classes, and the students come in and they want to be athletes or actors or musicians. They leave and they want to, you know, a large percent of them want to be in the sciences. They want to do engineering. They want to go more into technology and math. So it's a really, really broadening experience. Next slide, please. Another area where we're seeing benefit is the excitement, the recruiting piece of this. We have a school that we work with, and they got a 3D printer, and they were using it for a week. They saw students that they had never seen before, because these students wanted to come down and see what was going on in their classroom. They met parents they've never seen before, because parents wanted to see what was going on. This really, really enhances these STEM areas. When I went to school, my experience with physics and engineering was building a bridge out of toothpicks. It was a terrible build. Mine failed immediately. I didn't have the ability to go back and change it. The flaw was in, obviously, the system. But these students get the access to make an engineering decision, modify it, test the results. It's truly a powerful reinforcement of what they're learning. It's promoting innovation. We get these students that are coming to instructors and saying, I've got an idea, and the students are running with it. We have a class that we work with where they, you know, this is a university class, they're positioning this opportunity with the business school, with the design school, and with an engineering school. So this one class that they offer, it's about a toy design, but they pair, and they've got a certain percentage of business school students that can get in, a certain amount of design, and a certain amount of engineering. Then they pair these these three different majors on teams, and these students on these teams, they work as a little company, much like what you're seeing with these robotic competitions out there today. Even at the high school level, these students get to work on a team, and they're forced to work with people that are doing outreach and marketing and people doing manufacturing. Education is changing. It's changing for the better, and a lot of it has to do with the technology that's offered. Next slide, please. You know, the old way of teaching CAD is you draw something and you print it out on a plotter, and that's what you have. Or you can actually manufacture it by using the skills you have in the subtractive way. But typically, teaching in the subtractive skills, the CNC, the mill, the lathe, that takes a true skill. 3D printing does not take the skill. It is like an inkjet printer. What takes the skill is the design work, and the students are already doing that in the design classes. So now they have the ability to go beyond that piece of paper, that plotter paper, that blueprint, and they actually get to touch a physical object. They get to modify it. They get to make a choice of, I like it, but it doesn't feel that right in my hand. These are the same decisions that CEOs are making at companies before they choose to go and manufacture a new product. We're seeing it happen all over. The classroom is changing. We're going to more hands-on. We're going to more project-based. And they're doing that for a reason. It works. People learn better. They retain more when they actually perform an activity. We say it internally as fail fast. Failing is good. Failing is outstanding if you get the opportunity to modify that failure and turn it into a success. There's no better way to learn. Then these students get that opportunity to not only fail fast, learn, and get a positive reinforcement, then they have the capability to go back and teach their fellow peers, hey, this is something I tried. And so failing, learning, and then teaching beyond that is promoting true solutions. You know, and the final point on this page is personalize the learning experience. So many students now get to walk away with something that they've created, something that they've mastered. And it's not taking months or an entire quarter to produce that. Now it is based off, I know my design, I know my CAD, now I can produce things because I have a piece that can actually manufacture for me. And I don't have to know the ins and outs of it. Next slide, please. This slide, we're focusing on the university practices. We have a lot of universities using our equipment, and it ranges from the mechanical engineering lab, so a lab that's got multiple printers and it gives access to thousands of students, to little pockets of design areas or a focused area where they're doing architecture. A lot of these shops or these labs, they run like a little business. You know, the students get access because they're part of a certain group, or they give access to all students, and it's for a fee that they get access to print parts. And a lot of these schools, universities, they have projects where one of the classes, you have to have a printed part at the end. Typically, they have an agreement with the lab that says, hey, we either get to subsidize parts from this, or there is no charge because it's part of the program. Great thing about it is these kids get involved, they get access, and some of them, they get excited to the point where they're changing majors. Or we've got a University of Maryland, a student switched to majors who's outside of the mechanical engineering group, so he took it upon himself and fought for and got a student lab. And now the student lab is open to all students, not just mechanical engineering. We've heard of students getting access to 3D printing and technical equipment in their dorm room because of the late night, the late hours. They need access when it fits for them, not when it fits for the lab. So we're seeing that opportunity, and they want to do changes to every little aspect of their model. These become portfolio pieces for these students, for them to go out and get an opportunity at a grad school, or even go out and get a job. We see the faculty and faculty and people in the lab working as a team. You know, they have to be on the same page because of timelines and projects being due, that they're going to set aside certain times in this lab for those students to go through. And it's good for the students because then they know that there's a target time for them to hit, and so it helps with their time management. These students get to broaden their horizons, have more access to tools. The wood shop, which is right next to the technology lab, so doing a mixture of wood making and 3D printing and finding the best solution to their problem. It's truly exciting, and those are the skills that these students need when they go out into that the workforce, because you're going to have a set limitations of tools to use. You use what you have. Guess what? Some of these kids are so experienced in 3D printing and the additive manufacturing and the design, they're going out to their employers and they're saying, I need this tool. With this tool, I will do my job better. That's when I really get excited. And they continue to improve not only themselves, not only their projects, but they're improving the courses they take with the curriculum pieces that they're allowed to help build and shape, but they're out there and they're changing businesses as well. Paul, I'll drop it off onto you.
Okay. Here you see some of the, for Javelin's post-secondary 3D printing clients. One of the very important things to remember with 3D printing is that it has to be integrated, you know, at the college and university, as well as with the elementary and high schools. It has to be integrated into the coursework. As an example, one of our university one of our university clients, they have a second-year mechanical engineering CAD course, and then also a second-year design course. So what they do is that they coordinate those two courses so that the students are learning the CAD as a future skill, but they're using the CAD to create the models that will then, in the design course, and that can then be 3D printed. And sometimes it's not a matter of printing everything in 3D, it's perhaps printing components. And it's also not confined just to the engineering. We have clients who are in the animation programs who are using 3D printing so that they can print out the characters. There's arts programs that are using it. So there's a whole other world of printing going on. We have clients who have a print shop at one of the colleges. Actually, Algonquin College has a print shop to be able to have students and faculty be able to print things out, you know, on other projects that they may be using. What we, you know, strongly recognize in the education aspect is that it takes, to start off, it takes two things to be successful. You have to have safe, what we see is having safe, reliable, robust printers from Stratasys, commercial quality that's going to work day in, day out. The other thing that has to go hand in hand with that is a learning curriculum. And at Javelin, if you don't have a 3D CAD software, that's where we can also work with you on the SolidWorks side. Just a note, too, if anyone was marking down some of the information on those top 5 practices from Jesse that Jesse was describing, we're going to have those available for you in some white papers, too. So Jesse, if you can speak a bit about the just about the materials available in a summary, and we're up to about 1 o'clock then.
Absolutely. You know, Stratasys believes in education, so we're investing. We've just launched a 15-week curriculum for the university and college level. We're in the process of producing modules to fit through the K-12 level. We're also working on certifications, deeper dives of modular certifications, because we're committed and we know that our audience wants that. And in order for you guys to be able to go out and get funding, you need to be able to make these students job ready. So. You know, we're committed to education. Javelin's committed to education, and in a true partnership, anybody that becomes one of our customers, we're committed to them as well. So I'll leave it to you, Paul.